Hey guys, I'm back with another video. So today we will be making a gravity model. So how actually gravity works. So first of all, we will the most important formula we want is the formula for the acceleration due to gravity. So the formula is this, and we don't. This is the constant. This is the mass of the object which is pulling the other object, and this is the distance between them. So now let's start with the code. So first of all, we will have to make a space, and inside the space there will be a 10 by 10 grid. So divide space, and inside that we will have a 10 by 10 grid. We will make the grid lines in the JavaScript section through loops, and we will have our center object, which will let us name it center, and also we will have our circle, which will be pulled by the center object, and our center object will be right in the middle of the space will be a square container, and our grid lines will be a 10 by 10 grid. Now let's first do the CSS part, because it doesn't require much logic. So height of the body should cover the whole height and width of the screen, and all the elements inside it should have the position absolute. Now let's make the styling of the space, and so I have chosen a good background color for it. So this shade looks good. I have googled it. And also if the circle goes outside the space, then we don't want to see it, so overflow is equal to hidden. And now let's make the center. So in order to make it, so let us decide its height first. Height and width would be same. It is a sphere. Height and width are basically the diameters. Width is equal to 40 pixel. Also, since it is a circle, this way it will become a square, so we need to also add this border radius is equal to 50%, and background color we can decide, yeah, red would be a good bright color. Now let's decide the position. So 20 pixel is the radius, so we will since if we write only 50%, then the top left corner of the div would be at that point. And now let's talk about the left will also be the same as the top. Now let's style the circle also. So the top and the left of the circle would be decided in the JavaScript section by us, and height width would be a bit smaller than the original bigger circle. So again, since it is a circle, we will apply a border radius is equal to 50%, and now background color we can keep green. Yeah. Also, yeah, we have also made a grid ID. So its height and width would be 100%, and top and left would be 0. It should cover the whole space. Now let us write the formula in the JavaScript section at the top, so that we keep this in mind. Now let us make a variable speed to keep everything together, and we can just this is the initial speed, and it will keep on changing as the acceleration due to gravity would be applied. As gravity is not a force, it is an acceleration due to the curved space-time. I will provide the link for the video that you can refer to in the description. And now position, let us keep it 1,9 for now, since we have a 10 by 10 grid, and we will also convert the position into. And now the center and the circle variables are for, let us keep the mass 2 for now, and space and body, these are all the elements. And now we will define the circle document center, the document.getElement by id center. So it refers to this element, the center red colored circle. Similarly, we can just copy the line and here as well we will change it. And now let's define the space is also an id, so yeah. Now our body will be a tag. You can also give body an id, like id is equal to body, and then simply do the same thing, but let us keep it as a tag only. Yeah, now we need to fill the space with the grid lines. Yeah, so our first of all, let's decide the height and the width of the space, since we haven't decided it. So we need the largest square out of the dimensions of the screen. So space dot style dot height is equal to space dot style dot width is equal to. Now we want to decide that the least values among the height and the width of the body, since the height and the width of the body is equal to the dimensions of the screen, since we have decided it here. So it will decide which one is less, and according to that its height and width would be equal to that. So if the width of the body is greater than the height of the body, then we want it to be equal to the height. Instead of 100 VH, we can also write body dot offset height, but both mean the same thing, because the height of the body is also 100 VH, so we can write 100 VH in order to use less letters. And if the width is less, then we will make it equal to the width. Now let's fill the space with the grid lines. Let I is equal to 0, I less than 10. There will be a 10 by 10 grid, and document dot get element by id grid. We haven't defined a grid variable because it is being used only once, so no need to define an extra variable for a thing which is used only once. So div style. Now how a line would look, this is how it would look. So top I into 10. 10 is because 100 divided by 10, we divide 100% into 10 equal parts. So we will do I into 100 divided by 10, which is I into 10 only. And left is equal to 0. These are the horizontal lines. Width would be 100% and height would be 1 pixel. And let's decide a background color as well. So we will keep a dim color. It would be white, but it would its opacity would be less. Opacity, or what we say alpha to it. The full form of A in the RGB is alpha. Let us keep it 0.2. Yeah. And let's close the div. And now the vertical lines would also look similar, except there would be some changes, like instead of height we will have to write width, and instead of width we will have to write height. Instead of top, we will have to write left, and instead of left we will have to write top. Okay, so our grid lines are ready. Now okay, so our the position of the circle, the green circle, is constantly changing. So let's make an interval for it, for the change of its position. Let's define a function, velocity function, and let's call the interval t. That will call the velocity function in every 0.02 seconds. So you can write 2 instead of 0.02 seconds because it takes 2 milliseconds as its value. Okay, so we will use the formula. We only need the ratio. The constant we don't doesn't really matter. So ratio was mass divided by distance square. So let us make a function for the distance as well. So constant distance is equal to, so distance is delta x square plus delta y square whole root. So since we are going to divide by the distance square, so we don't really need to waste our time in first finding out the square root and then finding out the square. So let acceleration is mass by distance. Now let us define the distance. So the distance would be position 0 minus 5, because the location of the center would be 5, 5 in a 10 by 10 grid, because 5 is half of 10, so its position would be at 5, 5. So yeah, so position 0 minus 5, and we will square it. We will use the math.power function and add it by the delta y. Yeah, so it is not actually distance, it is distance square, but since the distance function is giving the output as distance square, the actual distance square, so our step gets reduced, because at the end we will have to square it, so why to find out the square root unnecessarily. So let angle, our angle would be tan is opposite, or what we say perpendicular upon adjacent or base, so it would be delta y, the distance in the y axis of them, divided by delta x. Now if we see, wait a second, oh wait, this is the y, so this should be y and this should be x. X should be in the denominator. Now let's find out the x and y part of the acceleration. So x and y part, since sine is opposite upon hypotenuse, so x would be the cos because it is adjacent, the horizontal distance between them, so adjacent upon hypotenuse. You can imagine that a is the hypotenuse, so hypotenuse into adjacent upon hypotenuse is equal to adjacent, which is the horizontal gap between them. So we cannot use only sine, we will have to use math.sine, and math.sine of the angle that we have just calculated, and y is equal to a into math.cos of the angle. Yeah, wait, I have this should be cos and this should be sine, as we have talked about. Cos is adjacent upon hypotenuse, so if we multiply it by hypotenuse we will get the adjacent, and which is the horizontal distance, and same for the sine will be opposite upon hypotenuse, and opposite is the vertical distance. Yeah, so now in case like there is a repetition, for example tan 30 is also same as tan 270, so in order to exclude those cases, what we will do is we will take the absolute values of them, math.abs. This is just to calculate the absolute values, and if our circle is towards the left of the center, then its x-axis, its velocity in the x-axis should be positive, and if it is to the right of the center, then its velocity should be negative. So position 0 minus 5, if it is greater than 0, then it should go towards the left. It should if its position is greater than 5, then it should go towards the left, and if it is less than 5, if it lies towards the left, then it should go towards the right. And we can just copy paste it with small changes for the y as well. So this would become yeah. Now we will add the acceleration to the velocity, not speed x, speed 0. We have only speed 0 and 1. Speed 1. Speed 0 represents the x-axis of the speed. Speed 1 represents the y-axis of the speed. And here we add the x and y, the accelerations along the x-axis and the y-axis. And now we will add the speed to the position. Also we will, since we have added x, we will also add the y-axis of them. Now our position has been updated, but how can we take in the value from the position? So we can directly use it, circle.style.top is equal to calc we have used the calc because we need to subtract it by 10 also, because we have already discussed that subtracting 10 is very important, because we need the center of the circle at that point, at that position, not the top left part of the circle. So circle.style. We can just copy it. The similar process is going on for left, top and the left. Yeah. Now we have to check if they collide. We will just stop the interval, the calling of velocity in every 0.02 seconds. So in that case, we will first find out the distance between them. So we have already defined the distance function, so let us take radius, because actually the full form of r is radius only. So radius is equal to 250 I have calculated. You just have to imagine that it is just to calculate the collision, just to check if the collision is happening or not. Dot offset height or width. Height and the width are the same only, so it doesn't really matter. And now we will just check in case the positions are very close. I'll just tell you a brief description about it. So 25 has come from the by adding their radii, sorry, and 10 is by 100 upon 10, as we have discussed here, I into 10. And now we will divide it by the offset height, so that we can get the radius. Position 0 is less than 5 plus radius, and a similar process would be for the position 1 also, that is the y axis of the position. We can just copy paste it. There is a lot of copy paste, I know, but we can't help. We can't just use a loop for just only 2 repetitions. The number of lines would remain same only. So yeah, this is looking good. I hope this works. Wait a second. Oh, 2 is actually very less. There is an error. Distance has already been declared. Yeah, so I figured out the issue. So there was some issue with the interpretation. So let us, yeah, it is showing an error. Now it is showing some error with this part. So the problem is it is not able to interpret this as a shortcut. So there are inline functions as well, so it is not able to interpret this correctly. So our work would increase a bit, but there is no problem in that. Yeah, now I think there shouldn't be. Wait, let us reload it. And what is this? Oh, I have missed a C also here. So let us save it and try to reload it. Hopefully we see the output now. There was a C less here actually. No? Oh, the speed is quite fast. So we need to reduce it. Actually we can decrease the acceleration only. That would do the job. No need to touch the speed. And yeah, the initial speed, if we put 6 to 7, 8, 9, 10, so in that case also we need to reduce the speed. So speed 0 divided by is equal to 100. Since we are dividing everything by 100, we need to divide the speed as well by 100. The initial since the initial speed is now 0 only, so it doesn't really matter. Yeah, we were talking about the angle. So in case the position 0 and the x-axis of the position is equal to the 5, then the denominator would become 0. So in that case, for very large values, we need to handle such cases. So yeah, so if the position 0 minus 5 is equal to 0, so math dot absolute of position 0. Okay, we don't need the math dot absolute function in such a case. Minus 5 is equal to 0. So in such a case, we will take the angle 90 only. Angle is equal to 90. So 90 is math dot pi by 2 radians. So it takes in the values as in radians only, so we need to provide it radian value only. And if it is not 0, then we can declare our angle. Control C, Control V, and let's not declare it in the beginning, else it would show an error in such cases. क्यों एरर दिखा रहे हैं आप? क्यों? एक छोटी सी चीज मांग रहा हूं यार, शांति मन की. पर नहीं. कहाँ गलती कर रहा है ये तो बता यार. Okay, so now we can play around with it. So we can give it some initial speed as well. 6 comma 4 or anything. Yes, so first we need this position to be verified, and now so everything looks good, and I have also interchanged the positions because we are first calling the function velocity and then we are changing the speed, so this might as well makes produce some issues. I have changed the value of mass and now it looks good, and rest all is same. I have not changed anything. There was some issue with the servers only. The same function was being called again and again, that is why. So now it is looking very good. Now since most of the time the ball is outside the space, so let's call it closer. So you can see it is following a regular path, and so this is our code ready. So we can't say that this is the perfect model of the gravity, because there might be some values being rounded off. So this is nearly the perfect gravity model, and you can play around with the values. You can use this, and for example, if you want the ball to go, and this is, we can increase this thing. And now try. Or you can just simply calculate the acceleration, the radius, and the circular motion formulas and apply it here, and you can get a circular path. So thank you guys, please like, share and subscribe, and I've also shared the link of the code in the description. You can check that out. Also, if you want to understand that why gravity is not a force, I have also shared the link of the video by Veritasium. It's a great video, you should watch it, and follow me on SoloLearn. Please like, share and subscribe.